Hello guys, this is a tutorial video on discovering some real-life applications of combinatorics. We'll be talking about solving word problems involving it, and of course to develop connections between common things we do and mathematical concepts. We'll be dealing with 5 of them, and let's begin with problem number 1. Colorific. Here is the problem. Jeffrey is shopping at his favorite market to buy some food coloring for his cakes. In how many ways can he select 5 colors from the 9 choices in the rack? So you might want to pause the video and try solving it on your own first. After you've done that, let's proceed. The way I'd like to look at this is to look for a keyword. And for me, what stands out is the word select. The word select means or implies that we are just referring to mere selections, and once they are in there, no matter how they are arranged, it will just be the same. And that for me implies that we must use combinations, and the formula for combinations is as shown: n factorial divided by the product of n minus r factorial and r factorial. Here we have n as 9 since it is the number of choices we have, and r is 5 because it is the number of objects we must select from the 9 at a time. So let's expand these terms. 9 factorial is 9 times 8 times 7 and so on until times 1. 9 minus 5 is 4, so 4 factorial is 4 times 3 up to times 1. And 5 factorial is as shown. We have here the expansion, and now let's cancel some like terms. Since we have 5 factorial here embedded in the 9 factorial, we can cancel those two at the numerator and the denominator. And we are still left with the left side. We can divide 3 times the product of 3 and 2 and 6. Since 6 is just the same as the product of 3 and 2, we can cancel those two out. And we are also left with an 8 at the numerator and a 4 at the denominator. Since they are both divisible, 8 and 4 can be cancelled out, leaving a 2 rather in the numerator. Since 8 divided by 4 is 2, and 8 is at the numerator, the bigger number. Now we have 9 and 7 left uncancelled, and they will retain. Here is our final expression: 9 times 7, which are left untouched, and the 2 derived from dividing 8 and 4. We'll just multiply these values and we get 126 ways. Therefore, Jeffrey has 126 ways of selecting 5 colors from the 9 choices in the rack. There you go. We have done problem number 1. Let's go to the next. It's entitled Artsy Artsy for a reason, because suppose we have ArtPH, and ArtPH is an exclusive doodling club built by those who are passionate for the visual arts. Suppose there are 10 applicants who want to join the club, but there are only 5 slots left open. How many ways can the admin select 5 applicants? So let's go. Again, you can pause the video, try solving it on your own, and we'll proceed. Now let's see here the select keyword as well. So what do? Yes, we do combinations, and we have explained it earlier. Now let's substitute the values, 10 being the n, since it is the number of choices the admin can select from 10 applicants, and the 5 being the r, since it's the number of applicants they are to select from the 10 at a time. So let's expand the values. You have here 5 factorial and the 5 factorial. Since 10 minus 5 is 5 and 5 factorial is as shown, we can cancel Now, after we have expanded, we have like terms right here. 5 factorial embedded in the 10 factorial and another 5 factorial at the denominator. We can only cancel 1 in the denominator and cancel this at the numerator. And let's do that. Now we are still left with what's in the left side, and let's cancel 3 times 2. You see that? 3 times 2 is the same as 6. So we can cancel these 2 out. These 3 out, rather. There you go. And we're still left with an 8 and a 4. Remember, 8 and 4 are divisible, and they can be cancelled out. And we will still be left with a 2 at the numerator, since 8 divided by 4 is 2, and 8 is in the numerator. Although it may not be shown, but just keep it in mind. But anyway. Now we still have a 10 and a 5. We can still divide 10 by 5, and we're still gonna be left with 2 at the numerator. Remember that 9 and 7 are still left untouched. So now we have cancelled 10, 5, 8, 4, and 6 by 3 times 2. Remember that 8, when we divided 8 by 4, we are left with a 2. And when we divided 10 by 5, we are still left with another 2. So, multiplying these values, 9 times 7 times 2 times 2 at the numerator, we get 252 ways. Therefore, the admin of RPH have 252 ways of selecting the applicants from the 10 of them. Whew, are you still alive and kicking? I hope you are doing fine. You might be taking some notes for this problem. Problem number 3. Fully booked. Yes, this is for book lovers, you know. So let's go. A librarian is arranging the books in a shelf. She still have 5 books in her hand, but only 2 slots are available in the row she's currently in front of. In how many ways can the librarian place 2 books on the shelf if she decided to place the remaining books in a different shelf? Same routine, you can pause the video, then proceed. Now, we see a different keyword right here. There is no word select, no word choose, no word whatever that pertains to combination. Does that mean we are referring to a different way of solving this? Yes, it does. Let's look for a different keyword. And for me, what stands out right here is arranging. Earlier, we are not pertaining to arrangements, but now we do. And the librarian is arranging, meaning there can be several arrangements. Now, we are talking about permutations. And the formula for permutations is, tada! You see, we are lacking with an r factorial right here. Because the separate r factorial at the denominator of the formula for combination cancels out the number of possibilities of arrangements within the r itself. So, when we do not remove the r factorial here, we are not sparing the number of arrangements. So when we spare the r factorial from being divided from the n factorial, we let it be considered. We are now considering arrangements, and therefore we are now using the formula for for permutations rather. So let's continue. Let's solve and let's replace the values of n and r, n being 5 since it is the number of choices we are to exhaust from. 5 being the number of books at the hand of librarian, and 2 being the number of books she has to arrange. Let's expand. Since we have here earlier a 5 minus 2, that's 3, and 3 factorial is as shown. We can cancel the 3 factorial embedded in the 5 factorial by the 3 factorial at the denominator. We can do that. And we are left with 5 and 4 at the numerator. We are still left with 5 and 4 at the numerator, and multiplying these values, we get 20 ways. Therefore, the librarian has 20 ways of arranging the books in her hand in the 2 slots left open. It's stated that way that this statement right here, can the librarian place two books on the shelf if she decided to place the remaining books in a different shelf only means that the librarian is not already considering the three books that would remain to be put on the shelf. She would just put it on a different row. That's it. That's just the meaning of that statement. So we finally solved for the ways she can do that. And let's proceed to the next problem. Problem number 4. This can be again be tricky and somehow you might learn something from it. Here it goes. During a birthday party, the game The Boat is Sinking, oh those days, was played. And what is the total number of groups that can be made if there should be at least 3 and at most 5 participants in a group? You can as well take down some notes and try solving this before we continue. So I hope you done that. Now, let's look for some keywords as well right now. Should be at least 3 and at most 5. That seems a little tricky, isn't it? The way I'd like to look at this on solving it is to compare it to when I play Wordscapes. You know that game? Yes, it's popular nowadays. Woo, 2018. So, in Wordscapes, I have a circle and it is composed with letters inside of it. Now, let's just say that the A, B, C, D, and E here, the A, B, C, D, and E here, or the letters stand for the each of the members in the who wants to join the game. And the words that will be created or the collection of letters would be the collection of the group. Keep in mind that again, let me repeat. Let the letters be the members and the words that would be formed, or rather the collection of letters would mean the collection of members or the group. Now that in mind, let's continue. We still have to clarify some things since we have number of members in between 3 and 5, because it's when we translate at least 3, that just means that at most 5 and at least 3, that just means that the number of members should be greater than or equal to 3 and should be less than or equal to 5, meaning the numbers that would be included are those between 3 and 5, including 3 and 5. Now, since students are being talked about here, and students or people can never be talked about as one half, one fourth, they are not talked about in fractions, we are only to include whole numbers, 3, 4, and 5. Therefore, we are going to make groups of 3, 4, and 5 in the game. After we have established a firm comparison of our word problem with that of the game of wordscapes, and the letters A, B, C, D, and E, the representations of the participants, and the words that would be formed, or the collection of letters, stand for each group that would be formed, or the collection of participants. After we've done that, let's ask ourselves, how can we create, or how many ways rather, can we create a word with these number of letters? For creating a group or a word of 3 letters, we'll use the formula 5 combination 3, since we are selecting 3 members to form a group. And when we are creating a group or a word of 4 letters or participants, we'll know it by using the formula 5 combination 4, since we are choosing 4 letters to form a word from the 5. And when we are using or looking for the word or the how many times we can create a word using 5 letters from the 5 all in all, we'll use 5 combination 5. And since we're looking for the total number of ways we can do a group, we'll just add these 3 together. 5 combination 3 plus 5 combination 4 plus 5 combination 5. Now we'll be solving for the separate factorials or the separate combinations. Let's keep in mind that n is the number of participants, which is 5. For the first r, um, for the first case, when we will choose 3 as the r, or we will take 3 participants from the 5 participants to make a group at a time, we'll be using the formula for combinations 5 combination 3. And let's do that. Let's expand. Let's cancel the numerical terms that are like, and cancel the divisible ones, which is in this case 4 and 2. We're still left with the 2 at the numerator, don't forget that. And we're still left with 5 times 2, which means 10 ways. We have 10 ways for choosing 3, for creating a group of 3 people from the 5 members. Now, let's continue for the second case, when we are choosing 4 members to form a group from the 5 participants. Let's do 5 combination 4, since we are just selecting. Let's expand the expression. Doing that, let's also cancel the like terms. Now here we are left with just a 5 at the numerator and 1 at the denominator. We have 5 ways. And for the last case, when we choose all of the members to join and form one group, that's 5 combination 5. 5 minus 5 is 0. And 0 factorial, drum roll. Do you know that 5 or 0 factorial is 1? As being agreed upon by the mathematicians all over the world. And that is what we are going to use. Since 5 factorial divided by 5 factorial is just 1, we are still left with one way. There's only one way of creating a group wherein all of the members are in it. And that makes sense, huh? Since we are not considering arrangements, once they are there, that is one group. And no matter how they are arranged, it's just the same. After we've done that, we are to multiply, since we are looking for the total of ways we can do that. Therefore, we have 16 ways. And for our final problem number 5. Hot dog. Ah, what a name. So here it goes. In a hot dog factory, a taste test is being conducted to select 3 variants of the finest quality in no particular order among the 15 unique samples. 10 of them are categorized to be very good, and the remainder of which are of excellent quality. In how many ways, therefore, can the food taster select the choice hot dogs, given he should keep in mind a 2:1 ratio of excellent to very good quality hot dogs? Let's get down to business. It has been said that out of the 15 unique samples, 10 are categorized to be very good and the remainder are of excellent quality. 15 after being deducted by 10 is 5. Therefore, we have 5 excellent quality hot dogs. Let us also consider that we have 2 excellent to 1 very good hot dog ratio. to form a total of 3 hot dogs. We'll understand more of this problem if we visualize it through a tree diagram. A tree has in fact branches. And let's say that the first level of branches refers to the collection of ways we can choose 2 variants from the 5 variants, or 2 variants from the 5 excellent hot dogs. We have used the 5 combination 2 since we have chosen 2 from the 5. And then let's say that for each branch, we should also continue to choose 1 from the 10 variants of very good. So, if we have 5 combination 2 ways of selecting 2 variants from the 5 excellent variants, then for each way we also have to choose 1 from 10. We'll know the answer by multiplying 5 combination 2 and 10 combination 1. I encourage you again to pause the video and try solving it first by yourself. I guess you've already done that. Let's continue. Now we already know that we are only to multiply 5 combination 2 and 10 combination 1. First, let's do the 5 combination 2. Here we have the values 5 factorial over 5 minus 2 factorial times 2 factorial. Let's expand the values. Here we also can see, we can notice a 3 factorial embedded in the 5 factorial at the numerator and a 3 factorial at the denominator. We can cancel those two. We are left with 5 times 4 at the numerator and 2 times 1 at the denominator. 4 and 2 can be divided by each other and leaves us a 2 with the numerator rather. After being done with that, let's continue multiplying the values left in the numerator and the denominator, which is 5 times 2, which leaves us with 10 ways. Therefore, we have 10 ways for choosing 2 variants from the 5 excellent quality hot dogs. Let's continue with the 10 combination 1. We have here the values already replaced, and now let's expand them. 10 combination being shown, then factorial being shown at the top, and the 9 factorial, which is 10 minus 1 factorial times 1 factorial, which is just 1. We'll be canceling the 9 factorial embedded in the numerator and the 9 factorial at the denominator. Here we are only left with a 10 at the numerator and a 1 at the denominator, which leaves us with 10 ways. And now we have known these two, we are only to multiply them. Ta-da! 10 ways times 10 ways leaves us with 100 ways. Therefore, the food taster has 100 ways of choosing 2 from the excellent quality and 1 from the very good quality to choose the 3 finest quality hot dogs in the company. Wow, that's been a lot. But before I leave, we will be left with a quotation. Words of wisdom would come from W. W. Norton, 1997, in his Steven Pinker How the Mind Works. Journalists say that when a dog bites a man, that is not news. But when a man bites a dog, that is news. Thanks to the mathematics of combinatorics, we will never run out of them. Here we see the beauty of combinatorics, specifically permutation, as displayed by the importance of the arrangements of whether the dog would come first or the man would. It is true as it is in life. In life, as well as in the combination, we choose things. So when we do, let's keep in mind, as it is in permutation, everything should be in order. That's all. Thanks for watching. God bless everyone.